Today we're going to build a fully adjustable Siren on a solderless breadboard. Now this breadboard is probably different from what you're used to seeing. It's embedded inside a console, and the console has built-in components which makes it neater. The components include a DC meter, a phototransistor, which is a light sensor, a buzzer, a speaker, transformer, a relay, 4 push-button switches, a DP/DT switch, 3 potential meters, which are basically variable resistors, a row of LEDs, and an LED display with a power switch. This board works the same as a regular breadboard, but you'll notice that there are 5 slots instead of 1, which is basically like putting 5 breadboards together. Also, they are vertical to the poles instead of horizontal. The ground is on the bottom and the positive is on top, with a choice of voltage from 1.5 to 9, which makes it kind of nice. Today we're going to be using all three potential meters with the circuit, along with the transformer and the speaker. In addition, we'll need 3 capacitors, 2 resistors, and 2 integrated circuit chips. Integrated circuits come in all shapes and sizes, and they do all sorts of functions. The 2 we're going to need are a 555 timer and a 4046 phase comparator, which is basically an exclusive OR gate. Each chip has a notch on one end, denoting that this is the top of the chip, and the number 1 chip is the upper left hand corner, number 1, and then you count down from here 1, 2, 3, 4 all the way around and back up the other side. The 2 chips we're using today, I printed out the schematic so you can see it. The ground is the first upper, number 1 is a upper left hand corner, and then each pin, the input and output on each pin is labeled accordingly. I took the liberty of pre-installing the 2 chips. They are very sensitive to static electric charge, so they're very easy to fry the circuits. Moving forward, let's get started by installing our capacitors. Capacitors is measured in microfarads, and this one is 10 microfarads. And if you notice, there's a long wire and a short wire. The long wire is a positive and the short is a negative. So we're going to start by connecting pins 1 and 2 of the 555 chip, and number 2 is going to be positive. So we're going to go from K2 to J2, like so, connecting those 2 pins. Our second capacitor is going to ground the 4046 chip. We're going to ground pin number 9. Go straight to the ground with it, like so. And then the third capacitor, well, it's a ceramic capacitor, and it's a very low capacitance. And we're going to connect pins 6 and 7 on the 4046 chip. Like so. And that one doesn't have a positive negative side. Alright, then we move on to our resistors. Our first resistor is a 1 microohm, and resistance is depicted by the color of the rings on the resistor. And I could get into that, but that's a whole nother video. So with this one, we're going to ground pin 9 on the 4046 chip. There, and run it to the ground over here, like so. And the second resistor, we're going to ground pin 11 on the same chip. I'm going to go to O20, and then in the ground. Now notice these wires are bare, so when it's all said and done, we need to make sure before we turn on the power that none of them are touching, otherwise they'll short each other out. Okay, and now we're going to start connecting the 555 chip. We first need to connect pins 4 and 8. And you make sure put in the right holes, because otherwise we could fry the circuit very easily, as I have done so in the past. Okay, 4. And these kind of crisscross. So, all right, so we're good. All right, now we're going to ground that circuit. So we're going to go from pin 1 to the ground, all the way over here. And then we're going to run power to it. And we're going to run it to the 9 volt. That ought to give us a nice sound. All right, now we're going to ground the 4046 at pin 8 and pin 5. And pin 5. Very easy to knock these components loose while we're doing this, so we have to make sure we're putting them all back when we're done. We're going to power that circuit up. And we're going to give it 9 volts as well. We're going to connect our first potential meter. L1. And it's a spring connector, so it makes it quite easy to connect. And then we're going to run this. Now notice we just connected both integrated circuits to this potential meter. Now we're going to connect the second potential meter . And that one requires that we run power, and we are going to give that one 9 volts as well. Easy to knock these things loose while we're doing it. Yeah, but be careful. All right, our third potential meter. They kind of run together after a while. All right, K10. And we're almost there. Now we need to connect 4046 integrated chip . here. You need to connect it to the transformer. From there, we're going to ground the transformer. Like so. And the final step is to connect the speakers to the transformer. Okay. And like this. All right, so we need to make sure before we power it on, everything is in place. All the wires are pushed in. Now, when I turn this thing on, it should emit a tone, and this potential meter, the resistor, variable resistor, controls, changes the cycles per second of the tone. The top one controls the tone itself, and the bottom controls the pitch. So let's power it up and see what happens. And we have a siren. And if we do this, we can change the tone. If we do the middle one, we're changing the cycles per second. So it's going to speed it up and slow it down. And then the last one will change the pitch up and down. And there you have it, an adjustable siren.